Hey, welcome back to Craft and Crawler Week 8. So, since last week, I fixed up our tiles. So there was a few issues caused by the software I was using, and some of these tiles have become, some of it has sort of become unaligned to the pixel grid, which in theory shouldn't have actually been possible because it had been told to confine everything to make sure everything was moved by whole pixels and that that everything snapped to the pixel grid. But hey ho, it is what it is, and it somehow slightly unaligned itself in places, but I went through, I fixed it all up, and we now have our tiles are now back in a good condition. And I made a couple of changes to our camera. So I set it up to add this line, which is translating the position on our screen, to put it in the middle of the screen. So we're putting the camera in the middle of the screen, and then we're starting to do all the other maths, whereas formerly that was all done in our set position up here, and that just made the maths here a bunch easier to deal with. So I managed to simplify the maths here down, but I'm not entirely sure I'm happy with the camera as it is, and I think a lot of my unhappiness stems from how complicated this method is. The set position. So I think hopefully maybe we'll get back to this at some point today, and we can look to simplify it down a little bit, make it a bit more straightforward. And I think the main problem we have is the limits. And so I was thinking when I was creating the camera, it's like a lot of these components, I want them to be reusable to some extent. So I want to be able to reuse these to make different kinds of games and experiences in the future. And I was thinking that maybe in the future, not everything I build would have a sort of defined bounding box for the world. Or maybe I might not want to confine the user to within a defined bounding box of the world, but I think that in hindsight, I mean, if I'm going to do something that has a very large bounding box, if I'm going to do something that isn't sort of a confined space, and create a game that has a sort of playing field that isn't a fixed size, I could just set this to be a very large size. So like if I set it 1 million pixels in every direction, then that's pretty much going to give me much the same, right? And if 1 million isn't enough, then I don't know, 1 billion, trillion, quadrillion. We can just pick an arbitrarily sort of huge number, right? Eventually, we're going to get to a point where the data types start to let us down. So it's not, even though this was sort of infinite, it wasn't really infinite, right? Because there's only so much we can store in a number. So if we have it running from like max value to min value for the number, then in theory we've got an infinite what would have been the same as an infinite sort of world anyway. So yeah. So I think later we'll circle back to this, and I think I did toy with the idea of adding a rectangle class to our as a utility class to map our vector to, and I think we'll circle back and we will add that in. We'll add that in and we'll use that for our limits. We'll have a fixed sort of size for the world, and then we'll simplify a lot of this right down. But first up, though, I want to look at our maps a bit more. So if we look at the map rendering as we have it from last week, yeah, here we go. Very occasionally, I'm hoping this is coming through in the feed. As we move around, we can see some weird artifacts appearing, sort of black lines horizontally across and down. Oh, I've just realised that I'm quite dark as well in the camera. Hey, there we go. That's better. Let's get some lights on. But yeah, so we get these weird artifacts that sort of appear on the vertical and the horizontal as we're moving around, and they didn't seem to happen as much before we sort of zoomed in the map. So I'm assuming that this is partly to do with rounding and such, and that we're basically trying to draw things on fractional pixels, and the rounding may be skewing stuff slightly. So I think the easiest way for us to handle that is if we have a look at our map. So we're drawing this, so we draw each layer. And these are now getting transformed by our camera. So I think what we have is a problem of this causing a slight fractional offset in the position. So I think when we set our position, we probably want to floor the X and Y values. So flooring is basically just computer for rounding down. So we just chop off any decimal part of the number and carry on. So we've got a couple of methods in here. We've got normalize. So I think we want to add a floor method. And this will return a vector 2. And we're going to floor the vector components. floor the vector components in place. So with this, we will go self.x is equal to, I think it's math.floor, yes, x, and then yeah, so, well, I was hoping that would actually be a bit more of a friendly introduction. It's technically correct because the integral value will be the whole number that is small, and the one that is largest, the largest one that is smaller than or equal to x will be effectively whatever x is minus any decimal component. But it's but it's not the most straightforward of explanations. But with this, if we have a vector 2 and x is 2.5 and y is 3.25, this will then set that to x being 2 and y being 3. And because yeah, so I think that's good, and then we will return, and it will return itself. Okay. There, so we'll floor the vector components in place and return self. And then we'll go for another one. We will go for a floored function, which will effectively do the same thing, but return a new vector. And we will keep the same, keep this consistent with the code above. Okay. So then we get that. I do want to try and keep this a bit consistent with what we've previously done. So. Floor the cool. So we've got our floored vector. So this should round everything down, and then if we come back to our camera, when we set the position, we should be able to go floored, and then unpack, and then hopefully, if everything has gone correctly, see, fortunately it's now shuddering a bit. It's not quite as smooth. It's not too bad though, right? It seems okay on that. Oh, sorry, I'm not showing the game window. So we've got a bit of shuddering here now as we move around. So I was hoping this would actually be, so it's sort of, I mean, it's not too bad though. It's not too bad. It's only every now and then. I guess we have to get the movement into a weird. I think we have to get the movement vector into a weird sort of state, but. And it doesn't feel quite as smooth, but I guess it's because we're actually. So I think because we're zoomed in, it's set to allow us to. We're moving effectively a pixel at a time here, but because we're zoomed in, we're actually moving at 2 pixels at a time. I think. What did we actually set things up as when we created the camera? So when we create the camera, we set the scale at 2. Okay. So, sorry about that. I'm a little bit sick today, so the head is a little bit foggy, and I may need to sneeze at some point, but yeah, because we're zoomed into 2, we're moving at 2 pixels per frame. Which means that the map is moving 2 pixels across each time. So I think that's where the shuddering is sort of coming from, because the character within it is moving by 1 pixel, but the world itself is moving by 2. So is there anything we can do to alleviate that sort of jumpiness? Okay, so I think, so floor is giving us the jumpiness. We could try rounding. So rounding will potentially round up or down depending on whether or not, basically from 0.5 up we go, from 0.5 up we round up, from, and anything less than that we round down. do we have a math dot? Okay, we don't have a round. So we have seal and floor. Seal will always round upwards and floor will always round downwards. So we need to let's make a local round. Take a value. Round to nearest round value to nearest integral value, and this is a take a number. I guess it returns an integer. What do we want to do on this? If the let's have a quick. My cold brain is getting to me for a sec here. So let's actually building functions. Let's have a quick look at what other languages do. So let's have a look at Python. Python will generally does the sensible thing. Okay, so in this, so that rounds to even. I thought it's code. Oh, we do. I must have hit the button. So I think that's actually I don't think that's what we want either. Rounding to even will create the same sort of jump that we have now. We want to round to the nearest integral. So let's so I think what we can do is if we go floor the value, let's keep this consistent with the built-ins that I say that uses x. Okay, so we want x plus 0.5. So yeah, so 0.5 or above will go upwards. but anything below will go downwards. Except I think this will fail. Yeah, so that one, if so I want to go if x is greater than 0, then we do that. Else we want to return math dot ceil of x minus 0.5. Yeah, I think that's right. So for anything greater than 0 or equal to 0, we add 0.5 and then trim off any decimal. And if it is less than 0.5, then effectively we do the same, but we minus 0.5 and trim off any decimal. Yeah. So then when we round our vector, you could do x, self.x is equal to round self.x, and self.y is equal to round self.y. Function m dot rounded, and then copy is equal to m dot new self.x self.y, return copy dot round. Okay, so this will give us a rounded. Oh. So this is going to also return a vector 2. Did I mess that up in the previous one? No, okay, so we've got it correct there. Okay, so this is going to return a vector 2 as well. So so this is going to round vector to the nearest integral value. Let's expand the comments on these ones. Round vector components to the largest integral. The existing value. Round vectors. Vector components in place to the largest small integral value smaller than or equal to the existing value, and return self. Yeah. Round vector components. For rounded, and then round vector. Here we go, and then we want round vector components in place to the nearest integral value and return self. Why is this upset? Because we use a dot instead of colons. I will get used to that at some point, hopefully. It's a very bizarre language feature to differentiate between method and like method calls and function calls, like Lua does. Okay, so given our changes there, if we come back to our camera, what happens if we round now? So now if we round, okay, I feel like this is actually, yeah, I think this is a lot more smooth. Okay. No. I think now and then we still get a little stutter, but I think I'm going to have to give it a little play test and just see if the different rounding functions actually make much of a difference. So let's have a little test here. Yeah, I feel like sometimes, no, yeah, this is definitely worse, I think. I definitely feel like a bit of a shake. Oh, sorry. I can definitely feel a bit of a shake in the movement when it's flawed. And then if we go back to rounded, if we go back to rounded, let me try again. I mean, I'm not sure this is actually much smoother. I feel like this is actually not any smoother than we had before. So the rounding does not make a difference either. Interesting. So that's unfortunate. I was hoping the rounding was going to, well, the rounding solves the problem with the staggeredness, but it's introduced a new issue. And this here is the this is the problem with software development, is basically an onion, and as we peel back the layers, we find new smells, new and more frightening smells, and each piece makes you want to cry a little bit. But I think we can solve this. So our problem is the transformation of these large pixels into smaller ones. So if we take the position, times it by the scale, then round it, then we divide by the scale again. So now we are rounding to the granularity of pixels in the larger scale. So this should round at a zoom level of 1. It should round to individual pixels. At a zoom level of 2, it should round to half pixels. At a zoom level of 3, it should round to thirds of a pixel, and 4 to quarter of a pixel. So then when we zoom in, we end up realigned at whole pixels. So let's give that a go. And yeah, I think that has, okay. I think that's smoothed out. I think we've smoothed out our camera a lot now. So I think this is what we're after. We're moving smoothly. I'm not seeing any. Oh, sorry. Let me share the game window with you guys. Yeah, we're moving smoothly. I'm not seeing any shuddering anymore. We've got smooth movement again, I think. Okay. I think that is good. That's what we were after. Yeah. So okay. So I think this is what we're aiming for. Let's have a quick look with the floor function. oh. So if we are flooring it, do we get the same smoothness? And I think we do. I think the floor is going to be better than the round, purely because it's a simpler. It's simpler, so this is something that's going to be running a lot. It doesn't run that often. Round is probably a more accurate representation of what we want. Yeah, I think the rounded is definitely. I think the rounded might actually be a bit better as well. I think I was seeing a little tiny bit of stuttering on some of the diagonals with the floor, but okay. Yeah, I think this is good. Yeah, I think we are where we need to be with this now. So this is good. I can live with this. Okay, so let's come back to our engine and let's have a look at this rect. This rect class. So we'll have local m is equal to a table, local mt for the meta type table is equal to table with index equal to m, and then at the end we return m, and then we'll have a function m.new. For this we'll take left, top, how do we want to define a rectangle? That is the question here. So we can define it as, we can define it in terms of its corner and its size, or we can define it as in terms of its fort size. I think what we want to do is, I think we'll go x, y, width, and height. Rather than defining the 2 points, the top and the top and left and the bottom right points. We'll define the top left point and the width and height. So we'll define a table self and we'll return self, set meta table self to empty. Here I guess we want to have some properties on here. I think we'll define these as vector 2s. So local vector 2 is equal to require crawler engine vector 2. And we'll do this as vector 2 dot new x and y, and we'll have sizes vector 2 dot new width and height. And then I think we'll also have a an end method, I think, on here, which will be which will return self, which will return self dot position plus self dot size. So this will give us the bottom right corner. What are we missing here? No, that is... okay. So we can't call it end. So what is the bottom right corner? Is the opposite? No. Well, the opposite of a rectangle is probably, could be a lot of things, right? Position. Wow. Naming things is, as I said, one of the hardest things in computer science. I don't like bottom left as a name, or bottom right even. destination? No. Let's have a quick. Look. So here, let's ask old ChatGPT and see what it comes up with. What is the if the top right corner of a rectangle is its the top left. The top left corner of a rectangle is its position. What is the bottom right? No, that's actually giving me some maths to calculate it, which is not what we want. We've already got maths. What we want is name. Let's try it again. At the top left corner of a rectangle is its position. What is the bottom right called? Okay, so it's given the suggestions of max point, end position, or extent. Extent is I think extent could be a good. It's potentially not bad. Bad name. Yeah, extent. Okay, from a quick Google, extent is the correct term. So yeah, I learned something new today. So the extent will be the position plus the size. Okay. So given this new Rec2 class, then if we come back to our camera, I think we can then go Rec2 is equal to require crawler.engine.rec2. And I think we'll make this a rect2 class. And we're missing the magic comments in here to make it field will have a position of vector2 and another field with size, which is also vector2. How do we name the complements? This is a 2D rectangle using fractional coordinates. There you go. And this is our rectangle factory. Find the this is the extent. Get the there we go. We're going to get the position of the opposite corner to the corner of the rectangle to position. So the reason why I decided we were going to, the reason why I decided we were going to go with vectors instead of just drawing the x, y, width and height on the class itself, is that I think that will also make some stuff simpler when we come to creating our I think that will also make some stuff simpler when we come to creating our bounding box. Okay, so we have the scale. Screen is the screen dimensions. So we'll have the limits be the limits be a rectangle that we pass in when we create it. That means, and then and then this will be a this will then becomes a rect2. And we just do limits equals limits. So this becomes a simpler method. Okay, so then when we have our map, so when we set things up in our init here, this is what we're missing. We need to add the rectangle in here. So if we keep these alphabetical, rect2 will go before our texture alias. Here, and then when we come back to our initialization, this will be a rect2.new 0 0 size.x size.y. Yeah, so that will constrain us to the map. So I feel like this, Okay, so then we can go. I feel like that set position in there is slightly off as well. So let's actually just set this to the vector 2.new of 0, 0. So we won't actually set the position like that as part of the creation. When we have, but we might, instead what we'll do is we'll self dot we'll set the limits via that, and then in here we're also going to have a field we'll have a second limits value. No, I think overcomplicating things again. Need to focus. So we're going to set limits there. When we set the position, what we're going to do is we're going to have the offset. Local offset is equal to self.screen divided by self.scale divided by 2. We'll keep that as a vector 2. And then we need one more method on our vector 2 method. Which we actually wrote last time, but we didn't need, so I did get rid of it. But unfortunately, we're going to need to bring it back, which is the clamp method. Return a vector. Constrain vector components to be within the min and max. To be within the range of the min and max vectors. So function m.clamp self min max end, and then we want to go self.x is the minimum of max.x and math.max of min.x and self.x. So basically we look at the minimum, we take a look at the value of x and the minimum vector 2, and we take the biggest value, and then we take the result of that and we compare that with and we look at that value and the maximum, and we take the smallest value. So we do that for y as well. Okay, and then we return self. And let's put in our comments for this. There we go. So these are both vector 2s as well. Ooh. So we've got that, and then we want a clamped as well, which will be self, min, and max. And then we're going to go copy is equal to m.new self.x, self.y, and then return copy.clamp min colon clamp min and max. Oh. And then we'll put in our comments again. Components in place to be within the range of the min and max vectors, and return self, and the clamped one, constrain vector components to be within the range of the min and max vectors. There we go. And this is a vector2. Oh, and we have missed the M there. Okay, so this should give us a constrained vector. And then in our camera, we can now go take this value and clamp it between limit position plus offset and self dot limit dot extent minus offset. Oh, sorry, limits yeah, so we get, and then we can get rid of all of this. Okay, so we probably need to clean this up a bit. So no, okay. So we'll take the rounded value, return yeah. So what we're doing here is we're taking the offset of the screen. So we're taking the offset, which is the amount of, which is basically half the screen size, adjusted for the scale. So this is the offset, this is half the screen size in the native X and Y sort of scale of the map of what we're rendering, the actual game's canvas itself. before any scaling, etc. happens. So we have to take the size of our screen, divide it by the scale, and that will give us the, if we're zoomed in a factor of 2, then we're zooming back out here. And then we're dividing it up by 2 to get the actual position within the screen. Sorry, within the actual game world's coordinate system. So this is this will. Actually, I think. No, offset's probably a okay name. Yeah, so let's so we're gonna get in so we're getting half the screen size in the game world in the game world's coordinate system, and then we're rounding to this position rounded to so this is the position in game world. It's rounded to screen pixels. Rounded to rounded to the camera's coordinate system there. I think that's the better terminology there. And then constrain oh no, we don't return here, do we? We set self dot position is equal to this. Here we go. It's a bit too long for one line, so we'll put it on multiple. Round position game world to camera coordinate system and constrain to camera to be within the limits. So if we run things now, then hopefully this should work as it did before. So yeah, so we aren't able to sort of run the camera off the sides. I think we've simplified down the camera code quite a bit now by moving it to a bunch of handy utility methods on our on the vector2 class. We've now got a rectangle class as well. So okay, that has cleaned up our camera code a lot, I think. So something else. Okay. So we've got the we've got that. Something else I want to look at is if we sorry, excuse me. If we go to the Love2D wiki, is while I was having a nose through the documentation here, I was looking at the where is it? This sorry, it's going to be at the top here, isn't it? The sprite batch. Yeah. So so yeah, so the sprite batch can draw a single image over and over and over again to screen. As says, can be even more useful when the image itself is a texture atlas, which is what our tile sets are. A single image file containing many independent images. And by using quads to batch different sub-images from within the atlas can be drawn. So I think this will allow us to optimize the rendering of our tiles, is what I'm thinking. At the moment, our rendering is all done within the Lua code itself, and the Lua code, though fast, is not going to be the fastest thing in existence, right? By using, I don't know if there's any caching or anything that the sprite sets do under the hood, but it's at least going to be doing the rendering within the C code of the engine, which should run faster than our custom Lua code, like the Lua code that we write. So what I'm thinking is we can make use of the sprite batch, and in our and then when we look at our tile layer itself here, so instead of drawing each individual tile from the tile set, we could create a sprite batch that would then render like a chunk of tiles at once. But plumbing that in with the way that we've sort of structured things is going to be interesting. Because the tile set itself is rendering the individual image. So we tell tile set to render the image, but actually the tile set itself, we just tell the tile set what tile to render, right? But that actually then delegates the rendering of the tile to the tile atlas. Which then in turn delegated to the texture atlas, which then in turn calls the love.graphics. So I think what we can have is a function m.batch for self and so this will have a texture atlas and it will return a love dot sprite batch. And let's go back to here. So how do we create them? Okay, love.graphics.new sprite batch. And for that we need the image, which we have on our thing. Do we have an image? Oh, we have a texture. Okay, fine. Texture is fine. Number of sprites, or max sprites. Okay. So this would be the number of tiles on our map. And then usage. The expected usage of the sprite batch. The specified usage mode affects the sprite batch's memory usage and performance. So what do we have here? Dynamic. The object's data will change fairly frequently during its lifetime. The object will not be modified frequently or at all. Or stream. The object data will always change every frame. So, given we want to allow animated tiles, I think stream is potentially what we're after. Won't necessarily change every frame though, because our tiles are going to update every so often, right? So if we have them moving, even if we have them moving at half a second per frame, so if we have a water tile, it's got like a little ripply effect in it, and that is running at half a frame. Sorry, half a frame every half second. That is still going to be 30 frames per update. So it could be that we have that dynamic is the right choice. Well, what is a graphics buffer actually? Okay, this is a very low level primitive, I think. So I don't think we will need that. Text batches. I think that might actually be from a newer version of Love than we have installed. Yeah, we have 11.5 installed. Okay, so that's, but I think but this could also be useful for when we get around to adding some extra stuff for when we start adding like our dialogue system, menu systems, etc. So I don't know when. So what versions? So it looks like the releases are a bit hit and miss. Hopefully, okay. Well, hopefully by the time we get to adding our text systems and stuff, or well, even if we added it, we'll be able to come back later and improve those when that releases. So it looks like there is new and cool stuff on the horizon, which is always good to know. Okay, so back to the sprite batches. So we have a maximum number of sprites, and we have the usage. Sorry, yeah, max sprites and usage. So I think so we create one sprite batch, and then up front we can create a sprite batch. Create quads. Okay, so we can do all of our rendering in sprite batch before we render out to the screen. Doesn't really tell us though if this is going to actually give us a better performance. There's like no feedback sort of thing. There's no hints as to why we might want a sprite batch. So Instinct says that it will help us because it's gonna speed things up. It will do things in C at least it will do things in C rather than in Lua, and that we can speed things up there. So okay, so we've got add queue has been removed in 9. Okay, so we want add. So we add a quad. I guess X, Y are positions within the context of the sprite batch. And then we've got the same scale and the origin offset. The shear factor, okay. And this will return an identifier. So I think we'll probably have to keep track of these identifiers within things if we want to then update a tile. Turned ID is in the range of 0 to buffer size. If the buffer size is exceeded, the returned ID will default to 0 and the sprite won't be drawn. Okay, so I think buffer size is probably that max sprites that we had. I assume the max yeah, so the buffer size is okay. So max sprites is settable when we create the sprite batch, and then we can update it here. And I think then I think we can add one at a time. We can add one at a time the various tiles. Sprite batch.set. Okay, and then if we need to update a tile, so for our animated tiles, for instance, we'll need this. So I wonder if some of this is actually offloaded to the GPU, which would make it much faster. We also have a draw range. This is a shame. I was hoping this would allow us to restrict based on X and Y positions, but it's actually just the range within the sprite batch. So I don't think we want to render the... So I'm also thinking we probably don't want to render the whole layer to one sprite patch. Unless when we draw love dot drawable, no, sorry, we won't draw, love.graphics.draw. Maybe we want to think I saw something about scissors. Could that be what we're after? Because we want to, if we're going to draw the whole layer if we're going to compress the whole layer down into one sprite batch, I'm just thinking for now our map is pretty small, but in the future when we're starting to build up large levels and maybe we've got 1,000 tiles across and 1,000 tiles on the Y as well, then that's going to be a huge image, right? So we probably don't want to render the whole thing when we're only going to actually see a very small window of that. So so there is a scissor. So set or disable scissor. I think this is I think this will still render things in the background, but then it will restrict what parts of the screen it updates. Okay. So I don't think that's what we're after, but if we then if we draw coordinate system, apply transform, it's origin, pop, push, rotate, shear. What does shear do? I have absolutely no idea what that's doing. A bit of extra reading for the future. So okay, so I think check my get can. I think what we want is I think we want the sprite batches. We just want to know if we can draw a subsection of a sprite batch. So that we're not rendering, as I said, a huge map each time when we get to our procedurally generated maps. So when we look at the draw, no, here we go. Level of graphics of draw. Comes to drawables, subtypes. We have our sprite batches in there. Okay, so if it's a texture, we can use a quad, but not for other things. So we can't draw. So we can't draw a subset of the sprite batch. Objects drawn relative to their local coordinate systems. The origin is by default located in the top left corner of the image and the canvas. The image and canvas objects. All scaling, shearing, rotation arguments transform relative to that point. It's possible To rotate an object about it, for example, note that the offsets are applied before rotation, scaling, and shearing. Scaling and shearing are applied before rotation. The right and bottom edges of the objects are shifted, angle defined by the shearing factors. When using default shaders, anything drawn with this function will be tinted according to the currently selected color. Set pure white for the object's original color. Okay, so okay. So I think we've had a look at this a bit. So I think we'll start off. We'll have one sprite batch for the entire layer, and we'll render that out. And then I think later what we might need to look at is maybe splitting the map into individual chunks. And those individual chunks will each have their own sprite batch. And then we'll just render the chunks that are visible on the screen when we actually draw the map, which I think will give us the best performance. But I think as a stopgap, just having the sprite batches will be a good start. So I think I'm going to add another param to this of max sprites, I think it was. So max sprites, and that will be a number. And we'll have a param usage, and this is a sprite batch usage, which is in turn dynamic, static, or stream. So then here we'll return love.graphics. Love.graphics new sprite batch. We have self.texture. Max sprites, and then we'll go for one of these. What does it default to? I think we'll make both of these optional so that they can be passed, they can be skipped, and they'll default to nil, and then we'll get the defaults from Love2D. Okay, so then next on top of that, we're going to want a new function, a batch function on this, and in this case we will want data width and height. Yeah, data width, height, and usage. Let's go for that. And self. Just thinking, what we're missing is a means of updating the sprite batches once they come back. So we might actually need yeah, we might need a class that wraps these to allow us to then update them in a sensible way. No, this isn't. Okay, yeah, no, I think this works. So what we're also going to need is a function m dot add to batch self index x and y. And then this we will, sorry, and we'll have a batch. Yeah, so we've got a texture atlas. This will be a sprite batch. Index will be a number, and x and y will also be numbers. What we'll do is batch dot add. Sorry, batch dot add add a pod relating to index. We'll have the x and relative x and y's. So that should then render the object within our tile atlas. Okay. So this creates a sprite. Creates a sprite batch for the using the given texture atlas. and this will add a specific asset from the atlas to the sprite sheet given position. Okay. So now we want to batch the tiles into the atlas. So we've got, this will be similar to the draw method. So we want for tile, oh, for index tile dash tile in iPairs data do end, so this will loop over each one. And then we want to do then we want, oh, no, we're going to want our batch first, so equals self dot atlas batch, and we're going to have width times height will give us the maximum number of tiles. So and we don't think this will update very often. Well, sorry, we don't think this will update every frame, but it will update often. So that was dynamic, if we remember right. Let's close this side panel. So we're not going to need that for a while. Okay, so we have our batch, and we have our data, and we're looping over each item, each tile in that data. We get the index. So we want to self.atlas.add to batch the batch, and then we want X and Y positions. So this will be X will be the if we floor X is equal to index modulus of width. So the modulus is basically the reminder from the division. So we will do x divided by width, and then the remainder of that. So, for instance, 5 modulo 3 would be 2, because 5 divided by 3 is 1 remainder 2. So this will give us, and that will give us the x position. And y is equal to do we support okay, no. And y is the floor of index divided by width. And then we're going to draw things at x. Okay, so x is going to be x is our tile coordinate, but we want a pixel coordinate, so that's going to be times self dot so tile set has atlas and terrains. Yeah, the atlas has the width and height, doesn't it? So be self dot atlas dot the atlas doesn't asset size, that's the one. So if we come back, yeah, so if we come back to here, so we're going to want self dot atlas dot asset size. We'll make that I think we'll allow the reading of asset size off of here. Okay, we'll make that public, and then here, yeah. So we want x is equal to the size dot x, and the y is the tile y, the tile position y times the size dot y. That should give us the thing. Then we can actually avoid the local variables here by moving these calculations inside here. So here we pass the batch, these two offsets. What is this subset about? So it's got the texture atlas, it's got the batch. Sorry, we're not passing the index. Here we go. Yeah. So we add to the batch the width. Sorry, we take our sprite batch. We take the index of the sprite within our texture atlas. We calculate the X and Y positions. I think that should do it. Okay. Yeah. So we could create a sprite batch from tiles. Create a sprite batch. In the given tiles, given tile data, so we've got the sprite batch now. That is, and then we can go up one layer further to the tile layer. Then when we instantiate the layer, we can add a private field. Which is a love.sprite batch. Then we can add a local function. Batch, which will take the data, the layer size, and the tile set. And this will do local batch. Actually, no, it doesn't even need a function, does it? So self. So yeah, when we're here, we go. The batch is equal to tile set batch with data layer size.y. Call this dynamic. Oh, I forgot, sorry, I said this is dynamic here, but we can actually pass the usage through from the top level here. Yeah, so our tile layer now batches up. Creates a tile batch, and then when we come to draw, we should in theory actually be able to go, oh, sorry, we should be able to comment all of this and do love.graphics.draw local.batch, self.batch, zero, 0, 0. Now if we hit F5 and see, okay, that did not go as expected. Texture Atlas, Lua 101. So Texture Atlas, line 101 is here. This is a quad array. The index. Okay. Something a little bit funky going on here, but let's see if we can debug it. I suspect our problems are in here. Add to batch. Okay, index. So here it should be tile. Let's run that again. Okay, oh, sorry, at the breakpoints. So still not getting what it should do. Let's see what we're getting here. So for data, yeah, so it was overflowing because we had a large number of tiles. So there's 600 tiles, but not that many. Sorry, 600 tiles on the layer, but not that many in the tile set. So that was why first time around we had a problem. The width we have is 30 and 20. Those look sensible. Usage is correct. So we're creating a batch with width and height. The usage set. So if we look at batch, that's set. Let's open the debug console. What is it? Batch.get. Oh, sorry, colon. Okay, so we've got 600 tiles in our batch set, so that all looks good. Let's good one. So our first one, we have index. Index of 1. So batches us batch tile is 15, which is a valid tile. Our positions. Step into this and have a quick look at the values that are passed here. Okay. A slight problem with X and Y positions, but that just means everything should be shifted over one, not that there should be a problem. Then if we have a look at the quads, we have quads to 256. We're asking for 15, which should be in here. If we put so these are all valid tiles that we're being asked to render. So skip through them. Okay, so I can't see anything immediately wrong there. So let's actually print the index, which is what appears to be out of bounds. And then we'll run again. Okay, so we've got our error. So the error is rendering tile 0. I think this might have something to do with how we load in the map. So when we load, when we draw. Okay. So what we're missing is this. Okay, yes, I remember now. What we're missing is that the tile is you basically have tile 0. Tile index 0 represents no tile. So when we iterate over the tiles in our tile layer, here we go. In the batch, the tile set. Here we go. So when we iterate over the tiles in the tile set, here, if the tile is less than 1, then there's no continue. Okay, so if the tile is greater than 0, then we add it to the batch. There we go. So now, if we run again, Okay, it's now entire layer on 53. Bad argument to draw. So when we try and draw, and that is because in our tile set we forgot to return the batch. So we create the batch, we update the batch, and then we forgot to return it. So now we're returning it. Oh. So, there we go. So we're returning a sprite batch. Now we run again. Then here we go. Okay. So we have this. We have a weird oddity in the top corner. Okay. Everything's off by 1. Weirdly though, even off by 1, it doesn't look that bad. It's quite. But okay, let's close that. Let's have a look at the problem we had with the. So what I think what we want here is index -1 and index -1, because at the moment, because it's one indexed, it's ending up slightly over from where we want it to be. But now if we give it one last run, have a look, then here we go. Okay, so this all looks to be rendering fine now. Although, actually it's slightly off though. That's because we are missing okay. We're missing the offset on the there. So if we go to the tile layer and we draw, we have the offset width and the offset height. Which I was saying half of those, so tile width, here we go, tile size.y, because what we want is to get back onto our slightly offset grid. I feel like this offset should actually be a part of the map itself of the layer. So I think actually we want a field. We want an offset which is vector 2. Change the signature here. So we have the layer offset. If this was like a released library, then we probably wouldn't update the parameter orders like this, and we wouldn't drop a new parameter in the middle, but as it's internal for now, maybe we will release our map engine at some point as a separate component that others can use, but for now I think it's going to stay it'll stay part of this. It'll stay as part of our engine. And while it's internal, we can sort of mess around with this stuff a bit. Well, while it's internal and it's just us working on it, just me working on it, and there's like no need to update people. We can sort of mess around with the signatures. If there are multiple people working on this or so on, then we probably would have had to have appended it to the end. Okay, so we set our offset, and then when we draw, I think this should be self dot. This should be self dot offset dot x and self dot offset dot y. And then when we load the map, this is a value coming straight out of the map itself. So if we have a look at the data itself, we have where is it? Layers. And here we have offset X and offset Y. So when we are so where's our tile map? So when we are loading tile map and we are going over each layer, we want a vector2.new item.offset x and item.offset y. Yeah, I think that is what we're after. And then if we run the game now, then I think these tiles are back to where they should be, which is offset by 16 pixels. Yeah, which gives this little island, puts this little island in frame, and then the water to the side is cut off. That was how I noticed it just now. But yeah, okay, so I think this is good. We have overhauled the map rendering now, so it's now using sprite batches. We've overhauled our camera so that it is rendering on the pixel grid a bit better. So we've not got those visual artifacts creeping in. We simplified down our camera so that it's now rendering with slightly more sensible. Well, it's a lot. The logic is a lot simpler, and we moved a bunch of it into our vector classes. We now have a rectangle primitive as well, which gives us a base to start building some other stuff like collision on. So all in all, I think actually this has been pretty productive. The sprite batches, I think maybe we will have to look at in the future and see about splitting our maps into chunks. So maybe each 16 by 16 square of the map becomes its own chunk or something. And we create sprite batches for each of those, and then so when we're up here in this corner, we'll have like we'll have sort of that top corner chunk, and then the ones below and to the side would creep in. I think we'll have, yeah, I think we'll have to have a bit of a think about how we'll manage large maps. But then again, we might actually start loading some large maps in here, and it'll all be fine. So there is that as well. So I guess we might never actually need it. But yeah, this seems a lot smoother and a lot nicer now. And I guess it will be smoother, right? Because we're rendering the map once. At the moment, we're rendering the map once when it loads. Going forward, when we start to look at animated tiles, I'm not looking forward to making animated variations of all these water tiles, but when we get there, then I guess it'll update maybe a couple of times a second, but max. But still, it will be a lot less than often than we update now. So it'll be a lot less than every frame. So yeah, I think this is actually looking pretty good. So given that, let's go tidy some of this up. So we now have no real need for this drawer in the tile set. We can take that out. And in the tile, we'll leave the one in the tile atlas because we'll need that for our animations and our sprites. We don't need all of this extra code in the draw function, so we can now just render our batch out. This is actually pretty straightforward as well. So when we start adding methods to edit tiles on the map individually, we can maybe call this from that, or we can add some more primitives to update the batch. I think that might be what we do instead. So I think at the moment we have on our tile atlas, we have a add to batch. Let's get rid of that print. I think in the future we'll also probably have a set in batch. Actually, I think let's call it batch add. So then in the tile set, when we render, batch add. I think later we'll add a batch set to go with this. We might even, maybe it's even potentially worth wrapping the batch itself, so that instead of passing the sprite batch around, maybe we'll have an atlas batch. That would keep reference to the atlas, but then instead of having, maybe at some point we'll change this. So instead of passing a sprite batch around, we'll pass around an atlas batch, and that atlas batch will have the sprite batch on it, and we'll have the draw method on it. But what we'll do is we will have we can have like an add method and a set method on that batch, on that sort of Atlas batch, or I guess it's a asset batch, or whatever we decide to call it. So that will then have the add, it'll have the set, it'll have other helpful utility methods that we might need to use to interact with the batches. And then this method here can just return back. This can return back that, that new type. And then when we're in our tile set and so on, we can then interact with that. I think that's a problem for another day. As it stands, I think this is in a good shape. As I said, I think this is in a good shape. Let's give it one last run to make sure we haven't broken anything with those last minute tidy ups. And yeah, it looks like we're all good and everything is working fine. So yeah, I think I'm going to call the stream here. If you have liked the video, give it a like. If you want to see our future progress, then do give the channel a subscription and hit that notification bell, and I will hopefully see you in the next one. Bye.